Here we have problem number 25 from our review packet for Chapter 3. Now, there are a couple typos on there, so I blacked those out so we wouldn't get confused by the grammar mistakes there. So we have Iggy Azalea and Nicki Minaj sing bad and awful songs. And it takes them 10 minutes to record and 15 minutes to auto-tune a bad song. And it takes 15 minutes to record and 45 minutes to auto-tune an awful song. Now they have 1 hour recording time and 2 hours and 15 minutes of auto-tune time available. If Iggy and Nicki make $3.9 million per bad song and $5.2 million per awful song, how many of each should they record to maximize their profit and also ruin the music industry? Okay, well, let's see here. First, we have to have our assignment of variables, and I feel like usually it's easier if we write out our objective function first. We know what we're actually trying to find. Now, this last sentence here says, if Iggy and Nicki make $3.9 per bad song and $5.2 million per awful song, how many of each should they record to maximize profits? So how many of each, meaning how many bad songs, how many awful songs? So if we have our objective function being 3,900,000 per bad song, we'll use X for bad songs, and we have 5,200,000 per awful song, we'll use Y for awful songs. That would give us our total profit. So for our assignment of our variables, X will be our bad songs, Y will be our awful songs. Lovely. Now it comes time for our inequalities, our constraints. So let's look at the information we have. We have reference to recording time and auto-tune time. So if it takes you 10 minutes to record and then 15 minutes to auto-tune a bad song, and it takes 15 minutes to record and 45 minutes to auto-tune an awful song, and you have an hour of recording time and 2 hours and 15 minutes of auto-tune time, it looks like there we can set up some constraints. So we're limited on our recording time and we're limited on our auto-tune time. So let's put these together. So for my recording time, for a bad song, it's 10 minutes for recording, and for an awful song, it's 15 minutes. And we only have an hour of recording time, but if we're in minutes here, we got to make sure we go to minutes. So it's going to be less than or equal to 60, because 60 minutes are in an hour. Let's look at the next one. We have 15 minutes to auto-tune a bad song, so 15 minutes for the bad songs. And then we have 45 minutes for an awful song, so 45 to auto-tune the awful song. And we have 2 hours and 15 minutes of auto-tune time available, so less than or equal to, and then 2 hours, 15 minutes. That's 60 plus 60, which is 120, plus 15, which is 135. Boom. There's my two super important, awesome inequalities. And lastly, we know we can't make it a negative amount of bad and awful songs, even though we wish we could. We would have X is greater than or equal to 0, Y is greater than or equal to 0. So those are my last two inequalities. All right. Well, why don't we start graphing them? We want a graph showing our feasible region. So this first one here, we have 10x plus 15y is less than or equal to 60. Now, some of you have been making mistakes with your x and y intercepts. You've been mixing them up so the graph looks kind of like opposite of what it should look like. So let's make sure when we are covering up this 15y and we get 10x equals 60, we get x equals 6, we are putting that dot on the x-axis. And then for my y-intercept, when I cover up the 10x and I have 15y equals 60, I get y equals 4. That's going on my y-axis here. So there's our first constraint there, and it's less than or equal to, so we know we're shading below the line. All right, now let's go with the next one. So if I cover up my 45y, I'm going to get 15x equals 135, so x equals 9. So I'll have the x-intercept over here at 9. And then when I cover up the 15x, I'm going to get my y-intercept, 45y equals 135. That means that y is going to equal 3. And notice how I went by 0.5 for my scale, so that way I'd use up more of the graph. So I'm really going like 1, 2, and so on and so forth. So here's my next inequality, and we're going less than, so we're shading below once again. Excellent. Now, notice I cross right here. Make sure you're very, very careful with your straight edge. Okay, it doesn't just matter that you're using a straight edge. What also matters is that you're going through the exact spot where you're supposed to go through. So when you're setting up your straight edge, make sure you're setting it up very nicely with those X and Y intercepts. Otherwise, you're going to have a bad time. All right. Lastly, we have our vertical lines. That's the X is greater than or equal to 0. Boom. And we have our Y is greater than or equal to 0. So my feasible region is this part right in here, which means that my corner points are here, 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 and here, the corners on our feasible region. So let's write those down. So there's my 4 corner points. Now we need to answer our question. Our question is asking us how many of each should they record to maximize profit. So we need to plug these into our objective function to find out what the profit would be. So if I plug in 0, 0 into this right here, I'm going to have 0 plus 0 gives me 0. So we're not making any profit here. If you don't record anything or auto-tune anything, if you don't put on any terrible songs, you're not going to make any money. So let's continue on plugging these in and get our answers. So once we get our values here for our objective function, we notice that our most profitable combination here will be making just bad songs. We don't even have to make any awful ones to maximize our profits. So our answer would be 6 bad songs, 0 awful songs. Wonderful. And if we were asked what's the maximum profit we can make, it would be the $23,400,000. That sounds pretty nice. Maybe we could make some bad and awful math songs, although those don't really exist because any song about math would be awesome.